This is how I got chlorophyll from leaves. Today, we'll be extracting pigments from spinach leaves, and then I'll use column chromatography to separate the chlorophyll and carotenoid pigments. Before we get started, I have some acetone chilling and heating up some hot water jacuzzi. On my ring stand, I have a sodium sulfate plug. I gently packed some cotton into the pasture pipette, followed by 1 centimeter of anhydrous sodium sulfate. The sodium sulfate plug will dry out the extract and make sure that no remaining water will pass through. I got 1.5 grams of spinach leaves and some scissors, and I shred and tore every leaf into oblivion. And then I just added them into my motor and added 2 milliliters of acetone at a time. It's very critical that I work with minimal light because pigments are light sensitive and will oxidize really quickly. Additionally, acetone has a boiling point of 56 degrees Celsius, so I gotta work really quickly. I can't multitask, but I will grind the spinach with my pestle to release the plant cells and to expose the pigments to the acetone, and to ultimately dissolve the pigments in the acetone. I transferred the extract into a centrifuge tube and centrifuged it for 3 minutes. I ultimately want to be at the 2 milliliter mark on my centrifuge tube. Ta-da! I transferred the supernatant into another clean centrifuge tube. The supernatant is the top organic layer that is very dark green and where the pigments are dissolved in the acetone. My bottom layer and the remaining solids will be discarded. I added 2 milliliters of hexane and 2 milliliters of water to my centrifuge test tube, vortex mixed it, and put it in the merry-go-round machine for a minute. We vortex mix it to break the emulsions, and we centrifuge to prevent any more emulsions, which is why we use 2 milliliters of acetone, hexane, and water. From here, our top organic layer is the extract, nonpolar pigments dissolved in the hexane. Our bottom aqueous layer of acetone dissolved in water will be discarded with the pasture pipette. Guys, I messed up. As you can see, my extract is way too light and will not get as strong results when I do my TLC. I probably added too much acetone or hexane, so I'm going to grab some more pigments to carry out this lab. I pipetted the extract into the sodium sulfate plug. When most of the extract has been separated, I'll add 0.5 milliliter of hexane to the column to extract all the pigments from the drying agent. My extract test tubes get to relax in the nice jacuzzi I prepared earlier to evaporate to complete dryness. We want to evaporate the hexane and any remaining acetone because the extract is too dilute. To make my Alumina chromatography column, I packed cotton into the pasture pipette and added 5 milliliters of alumina and leveled it. We want enough alumina so that we could get a good separation. I added 2 to 3 milliliters of sand to protect the alumina from divoting. Then I wet the sides of the column with hexane, and throughout this process, I don't want the column to dry out. I'm using hexane to start the elution process. I added 0.5 milliliter of hexane to redissolve my dried extract test tube. I slowly added half of the redissolved extract to the Alumina chromatography column by inserting the tip of the pipette down into the column. I followed that up by adding 4 milliliters of hexane next, and will wait until the green color penetrates the alumina before adding more. I don't want my top reservoir to be green. Objectively, I want to be collecting the yellow band. The yellow band is beta-carotene and is very nonpolar. This is why we use nonpolar hexane with polar alumina. Anything polar will stay up top, and nonpolar will go down the column. I will eyeball this throughout the elution, but we want to increase the polarity of our solvents. I will eventually use 70% hexane with 30% acetone, then just acetone, then 80% acetone with 20% methanol. I don't want to jump straight into my 80-20 because I still have my green band of polar chlorophyll up top. Ultimately, I want to collect my yellow band first and my green band next. So I messed up again and I packed my column way too hard and my green band is so slow. So I got a latex bulb and pushed the band through using pressure. I evaporated my solvents from my test tube and added 2 drops of hexane to them. We just want these to be very concentrated. Now, I'll perform the thin layer chromatography technique. I spotted my TLC silica plates, slightly drying in between just to get dark spots on each. I don't want big spots or they might cross over each other. In a jar, I'll add 70% hexane with 30% acetone, about an inch from the bottom, along with filter paper, and I'll let it saturate. I'll put my plates in the jar, making sure that the sides don't touch the filter paper. During this time, the spots will have a little race. But I was racing against the time, so I had to take out my plates too early. If I had the time, I want my solvent front to be 1 centimeter below the top of the plate. I calculated my RF values by dividing the distance that each spot traveled by the distance that the solvent line traveled. As you can see, the nonpolar yellow carotene traveled the most and the green polar chlorophyll traveled the least. It's also worth mentioning that silica plates are polar. which contributes to these results. The other gray spots are phaeophytin and xanthophyll. In terms of purity, the yellow band was the most pure. And that's how I got chlorophyll from leaves. I hope you have a terrible day.